and thank you for joining us today. My name is Kristin Hennessy-McDonald, and I'm the Outreach and Community Engagement Lead at Mini PCR Bio. As a part of that role, I'm the program lead for the Genes in Space contest. If you're an educator looking for some guidance about bringing the Genes in Space contest to your classroom, you'll be hearing from two who've done so today. I'm excited to be joined by Pam Schmidt, a former middle school teacher who used and still helps teachers in her area use the Genes in Space contest. Together, we plan to share our experiences as teachers who implemented the Genes in Space contest in our classrooms and guide you to the resources available on the Genes in Space website to help you get started. Just to give you a brief outline of the presentation, I'm going to share some fundamental information about the Genes in Space contest. Then Pam will explain how she implemented it in her middle school classroom. I'll talk about how I ran it in my high school classroom, and then share additional resources you can use to bring the Genes in Space contest to your school. The Genes in Space contest asks students to design an experiment to run aboard the International Space Station, or ISS. On the ISS, astronauts have been studying the effects of space for more than 25 years. There's so many things that we don't know about what happens to living things in space, and challenges that need to be solved before humans undertake long-duration space missions. Genes in Space lets students dig into topics that interest them and propose a space biology experiment. And each year, one experiment is selected to be performed by astronauts aboard the ISS. The best thing about Genes in Space is that it's an ideas contest. There is no hands-on lab work required. Your students can bring their own interests to their projects, enhancing student engagement by working through the process of experimental design focused on a topic that interests them. The Genes in Space contest is a great way for students to practice critical thinking skills, as well as demonstrate mastery of core life science concepts, such as the structure of DNA, mutations, and gene expression. The Genes in Space contest gives students a way to share these questions and possibly send their experiment to the ISS. The contest invites students in grades 7 through 12 to write a proposal for an experiment that would test or solve a biological problem related to space. There are only two requirements. First, there must be a genetic target. And second, the experiment has to use a piece or pieces of the Genes in Space toolkit. This is equipment from Mini PCR that are on the ISS specifically for this purpose. Students can apply as individuals or in pairs. One question we've gotten is whether the students need to be in the same class or even the same school, and the answer is actually no. The application must be sponsored by an adult. This could be a teacher, a club sponsor, or even a parent. The contest opened January 5th. And the application is due by midnight Pacific time on April 10th, which is a Friday. And there are no costs associated with applying to the Genes in Space contest. This is last year's winner, Julia Gross, attending the launch of her project to the ISS. Julia and her partner Isabel asked questions about using bacteriophages as a mechanism for treating bacterial infections in space. Julia said it best when she said, "I really hope that our experiment can advance the way that people can be medicated and fight off bacteria in space. As we look into long-term space travel and the risks that astronauts are already under in enclosed environments, it's a really important field to be putting our focus into." Once the experiment is flown to the ISS, an astronaut on the ISS performs it. This is astronaut Mike Finke, who performed Julia and Isabel's experiment while he was on the ISS. So the first step for students is to find a research focus. This is what I love about the contest. It asks students to take things that they're interested in and dig deeper into what's already known and what they can add to the research. After students have determined what is already known, they create a hypothesis or research goal to test it. Once the students have chosen their topic and the question they want to answer, They have to design an experiment to test their hypothesis using the Genes in Space toolkit. There are 3 tools in the Genes in Space toolkit. Students can propose using 1, 2, or even all of them as part of their experiment. We have resources on our website to explain in detail how each can be used. In the description below, you can find links to a webinar for each piece of the toolkit. Finally, students finalize their proposal using the 2026 Genes in Space application. We have the sample application and rubric on the website. There's even a Genes in Space hypothesis and experimental design checklist, which we've put together for students to both self-check and even peer edit their proposals. It goes through all of the requirements and allows them to ensure their proposal is complete. There are multiple ways to use the Genes in Space contest in a school setting. I'm going to pass it off to Pam Schmidt, who used Genes in Space in her middle school classroom.
Thanks, Kristin. Hello, everyone. It's great to be here with you today. I started using the Genes in Space contest with my 8th graders back when the contest itself was only a couple of years old. That's me in the picture. That was in July when I had the honor to serve as a judge for the Genes in Space finals. It was really amazing. I've been retired for 3 years, but I still go back into work with my former colleagues whenever they're doing any Genes in Space activities or anything to do with the contest. In the middle school standards, some parts of Life Science Standard 1 and all parts of both Life Science Standard 3, the genetic standard, and the Engineering Design Standard are supported by the Genes in Space contest. In addition to the content standards, doing the contest with your kids in class can help address several of the cross-cutting concepts as well as the science and engineering practices. Meeting the standards is wonderful, but I think what I really love most about using the Genes in Space contest with the kids is how much it thoroughly engages them. For example, kids often choose questions with personal relevance for themselves. Let's say they're way into sports. They might choose to ask questions about metabolism or muscles. In addition, using the contest can be differentiated for students who learn in all different ways and at all different levels. That actually leads to something really important to me that I would like to talk to you about. It seems like there are some teachers who feel they can only use the contest with their honors or advanced kids, with a science club or a special small group of students, which of course is fine if that's what works best for them. But it is such a wonderful learning experience for all kids. Our team decided from the very beginning that we wanted to include all of our students. That's a lot of kids. There were 4 of us every year with about 120 kids each. I think that's probably one reason why we won the Constellation Award for our region for so many years, because that's a lot of applications being submitted. But we felt that if we scaffold the lessons wherever necessary, it would be possible for all of our students to successfully navigate this level of learning and the contest application process itself. And we were right. They were able to do it. Using it with all of our kids was the single best implementation decision that we made. And I'd encourage you to think about doing the same thing with your kids. Since our week-by-week lesson plan or unit plan is available online, let me just talk about the main sections of our implementation. First comes introducing the contest to your student. This is where you really need to build the enthusiasm. You've got to be excited about it in order for them to get excited about it. In my intro, I would always say things like, you can be the next student to work with the Harvard scientists, or you can be the next student to watch your experiment launch into space. They're middle school kids. Talk about the prizes. Genes in Space does provide a sample introductory slide set that you can use and modify as you see fit. During the intro lesson, the kids get time to brainstorm for ideas of what kinds of questions they want to have answered. And boy, they can come up with some real doozies. Also during the intro, we utilize the many resources on the Genes in Space website that help kids understand what we already think we know about living in space. The tips for students section includes short videos on current space biology research. Those videos are done by the researchers themselves. There's also links to resources such as NASA's Space Biosciences site, as well as their Gene Lab. Using these resources help the students understand what is already being studied in space and what the next research steps might be, can kind of guide their thinking. For us, the next step in our classrooms has always been to teach some basic genetics. This is going to vary depending on the scope and sequence your district has for science. In our district, 8th grade is when the students get their first introduction to genetics. So we have to do some really basic lessons to build common understanding and vocabulary. Now, once you get all of your content taught, about 3 weeks before the deadline is when we really get started on writing the applications. In some schools, teachers do all of the application writing in class with the kids. In other schools, they don't do it in class at all. They have the kids do all the writing at home. We kind of try to aim for the middle. We successfully used an age-old teaching technique you may recognize, the gallery walk, to help kids develop a testable question. We were actually surprised at how well this worked. The kids get a clipboard with a piece of paper on it, and that's for them to write down any ideas they come across or anything they think about that really resonates with them so that they don't forget it. But more importantly, they also get a handful of sticky notes. And they take those sticky notes around and read each question, and they use the sticky notes to either make constructive criticism or ask clarifying questions for each of the research questions. For example, at this point, some of the research questions are still really too broad to be truly testable. So the kids give suggestions to each other about how to focus in what they actually want to study. Then it's finally time to get started on writing the rest of the application. The application, a sample one, is on the website. And we take that and embed it into a Google Doc that then we share with each student. And that will allows the kids to easily edit their application, but then it also allows us to have access to what their work is so we can keep track of their progress. After we review the rubrics and the scoring criteria, which is also on the website, the kids first write about the 2/3 of the proposal, the title, the background knowledge, the molecular or genetic target, and the hypothesis or research goal. We give them class time for this, usually a full class time, sometimes even a little more, and then they finish it at home. We let them know what day we're going to start the peer review next. For peer editing, we use a modified version of the ADI peer review form. ADI stands for Argument-Driven Inquiry. We use their form blended with the Genes in Space scoring criteria. The reason we use the ADI form is because we do lots of ADI labs during the school year, and so our kids are familiar with that tool and the process for using it. We always try to do at least 3 rounds of review, and by that I mean at least 3 different kids looks at each proposal and gives suggestions and makes comments on it. Then the kids get their feedback forms back, and they have time to make edits to that part of their paper. A couple days later, we have another in-class writing day, and the kids finish up their contest application, their proposal. The last thing they have to do is the experimental plan, and then we try to do another 3 rounds of peer review. And then finally, it's time to submit the applications. I do a final check, make sure they've got their name and contact information. Then I get the class's attention. We do a big drum roll. They hit that submit button and everybody applauds. It feels pretty exciting in there. The kids are having fun with it. I'm having fun with it. It's a great day. So there you go. That's how we've been using the Genes in Space contest with our middle school kids. I hope that helped a little bit. Thank you for your time today. And please feel free to contact me if you have any kinds of questions at all. Kristin, back over to you.
Thanks, Pam. While Pam worked with middle school students, I used the Genes in Space contest in my high school classes, specifically in my biotechnology class. Just to share a little bit more about me, I was a high school science teacher for 11 years. I taught a number of classes, but the implementation plan I'm going to share with you today focuses on how I implemented Genes in Space in my second year biotechnology class. You can see me here with the Constellation Award. which the school won for having the most submissions in a region for a single year. I used the Genes in Space program as a part of my overall approach to teaching biotechnology, which was focused on evaluating student understanding through a quarter project. The Genes in Space program was a valuable tool for understanding students' grasp of hypothesis creation and experimental design. The Genes in Space competition is a great tool for performance assessment in a high school science class. It can be implemented in any class that asks students to understand DNA structure, transcription translation, or genetic variation. I've highlighted the NGSS standards here, but the understanding of these core concepts can be found in a number of classes, including AP Biology and Anatomy and Physiology. I used this as my third quarter performance assessment in my biotechnology course. This quarter included standards on the structure of DNA, as well as communicating scientific ideas and experimental design. There are a lot of ways that you could implement this in your classroom, but I'm going to review how I did it. If you have any questions, please check out the Genes in Space website, linked below, or email us. The first thing I did was introduce the Genes in Space competition. I used resources from the Genes in Space website that include worksheets and videos to guide students through current space biology. Then I introduced students to the Genes in Space toolkit. There are a few ways that you can do this in your classroom. I used hands-on mini PCR learning labs, but access to hands-on equipment is not necessary for students to design their Genes in Space projects. One alternative is to use mini PCR digital labs to introduce students to the biotechnology concepts. The Micropunters Digital Lab is a free resource that guides students through identifying species through DNA testing. Once the students had an idea of the toolkit and the contest itself, they worked through a series of lessons to design their experiment based on their topic. Embedded within my lessons was the editing process, where students went through a series of peer edits. I wanted students to have at least 2 other groups look at their proposals each time they added a section. This allowed students to learn how to give peer feedback and groups to have multiple eyes on their project proposals prior to submission. Finally, I had students share their proposals in a short presentation. This allowed me to see how they would communicate their project to me and others. Now, Genes in Space and Mini PCR have a ton of resources that you can use to implement Genes in Space in your classroom. I'm going to go over a few of them, but please make sure to check out the Genes in Space website to take a look at all that we have for students and teachers. Everything I'm going to talk about can be found in the Resources tab on the Genes in Space website. There are implementation plans on that website. In addition to mine and Pam's implementation plan, there's a virtual high school implementation plan that can be found on the main page of the Resources tab. We have a detailed lesson plan that you can use, along with worksheets that guide students through ideation from putting together their complete Genes in Space proposal. We also included a peer review checklist for students to use that I talked about before. There are a number of video resources linked in the teacher lesson plan under the Videos tab under Resources. As I said, since I was in the classroom, Mini PCR has launched our digital platform, including Micropunters Digital. This free resource asks students to work through a scenario on the ISS to find an infectious microbe. I would recommend this to any teacher as a starting point for students to get excited about the Genes in Space program and allow them to learn about PCR and gel electrophoresis. If teachers want the opportunity to get hands-on experience and speak with other teachers who are interested in the Genes in Space program, Mini PCR has hands-on virtual workshops. For a discounted price, Teachers receive a class set of reagents and a Bandit STEM electrophoresis kit, along with an hour and a half of PD to review how to use the biotechnology equipment and how to get students excited about the Genes in Space program. The QR code will take you to all of our virtual lab offerings. The 2026 competition for Genes in Space is open now, and your students can turn in their applications anytime between January 5th and April 10th. Thank you for taking the time to learn about the Genes in Space competition. I look forward to seeing everyone's entries in April. Thanks.